Okay, so 4.6 notes is approximating with local linearity. So it says the tangent line of the function f of x at x equals a can give you approximate value of f of x for points close to x equals a. So concave up with a tangent line, we know our tangent line is going to be below this graph, if it's concave up. Okay, if it's concave down, we know that our tangent line is going to be above. Okay. One says f is concave up on its domain, and f of f is equal to 5, and f prime of 4 is equal to 3. What is the estimate for f of 3.8 using the local linear approximation for f at x equals 4? So here we can set up an equation because technically we're given a slope and we're given a point. Okay, so this right here is telling us our slope. This is telling us our point. So we can do that y minus y1 is equal to mx minus x1. Okay. So our point here is that 4, 5. So this is y minus 5 is equal to, and what's our slope? 3. And then we have x minus 4. Okay. So we can use this to approximate f of 3.8. Well, we could say let's add this 5 over. Okay, we're not simplifying from anything from this. We're simply just adding that 5 over, so we have y by itself. So that's 3 times x minus 4 plus 5. And then we need to find 3.8. So we're going to plug in 3.8 in for x. So we would say f of 3.8 is approximately 3 times 3.8 minus 4 plus 5. And you would type that in on the calculator and get the value 4.4. Okay, so based off of the 1 point and the derivative of that 1 point, we were able to get something to form that tangent line, right, an equation, and we're using that equation to approximate another value. Okay. Is this an underestimate or an overestimate? Any ideas? Underestimate, and what would be your reasoning? But do we know the actual value of that point? Because it's concave up. Good. So we would say this is an underestimate. Since f is concave up. So the tangent line lies below the graph of f of x, which means if this said the function was concave down, this would be a what? An overestimate. So it's based on the concavity if it's underestimate or overestimate. Yes?
Will it always be underestimate or overestimate depending on the concavity, or is it the numbers?
Based on the concavity. So concave up will always be underestimate, concave down will be overestimate. And that's just based off of where our tangent lines lie on the graph. Okay. Example 2 says the function f of x is equal to 5x minus 2x cubed minus 2 is concave down at x is equal to 1. It says find the tangent line of f at x equals 1. Okay, so we're going to do the same thing. We have x is equal to 1, which means we need to find our y value. Okay, so that's what we should do first. So I'm going to plug in 1 into my original function. So f of 1 is equal to 5 times 1 minus 2 times 1 cubed minus 2. Okay. This gives us 5 minus 2, which is 1. So now we have the point 1, comma 1. Okay, now we need to find the slope, which means we need to do what with that function? Take the derivative. So f prime of x is equal to 5 minus 6x squared. Okay, took the derivative of 5x, got 5. The derivative of negative 2x cubed, using the power rule, got negative 6x squared. And then the negative 2 went away. And then I'm going to plug in 1 into that derivative. So f prime of 1 is equal to 5 minus 6 times 1 squared, which is negative 1. So now we have a point and we have a slope, and so we can use the point slope formula to write the tangent line. So we would have y minus 1 is equal to negative 1 x minus 1. And that would be our answer. Okay. Part B says, what is the estimate for f of 1.1 using the local linear approximation of f at x equals 1? Remember, all we do is take the tangent line, and we're going to use that and plug in 1.1 for x to get our approximation. Okay, so I have y minus 1 is equal to negative 1 x minus 1. I'm just going to get y by itself, so y is equal to negative 1 x minus 1 plus 1. And then where I see an x, I'm going to plug in 1.1. So y is equal to negative 1, 1.1 minus 1 plus 1, okay, which means that I have f of 1.1 is approximately 0.9. And I get that 0.9 by calculating this part. Okay. 1.1 minus 1 is 0.1. Negative 1 times 0.1, and then I'm adding 1. Or just plug it into Desmos. Yes, that was your question. Okay, yeah, just plug it into Desmos. Okay. Okay, now it's asking if it's an over or underestimate, but what was the concavity in the beginning? Down. So since it's concave down, we know this is a overestimate. So this is an overestimate because f of x is concave down at x equals 1. Okay. And then last example, it says consider the differential equation dy dx is equal to e to the y times 2x squared minus 5x. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 2 equals 0. Write an equation for the line tangent to the graph of f at point 2, comma 0. So they're trying to mess with you by adding in those other words there. Differential equation and particular solution. Doesn't matter. All we know is that dy dx is what? Is the slope, right? dy dx is the slope, or dy dx is the derivative, which means they already took the derivative for you. Which means in order to find that equation for the tangent line, we have dy dx, we just have to plug in what values? Y and x, which is 2 and 0, based off the problem. Okay, so dy dx solved at 2, 0. Okay, so we have e to the 0 times 2 squared minus 5 times 2. Okay. Remember, anything to the 0 power is what? 1. Anything to the 0 power is 1. So e to the 0 is 1. So ignore it. We don't really need it. 1 times anything is not going to change that. So then we have 2 squared, which is 4. 4 times 2 is 8. 8 minus 10, negative 2. Okay. Remember, this is our slope. And if we have our point and our slope, we can now write our tangent line. So this would going to be y minus 0 is equal to negative 2 x minus 2. Okay. And do we need the minus 0 next to y? Nope, so this is just y is equal to negative 2 times x minus 2. So this is our tangent line. Okay. Then it says use the tangent line to approximate f of 2.2. So I'm going to plug in 2.2. So f of 2.2 is going to be approximately negative 2 times 2.2 minus 2. Which, putting that into Desmos, gives us negative 0.4. And that would be our answer.